Hey everybody, this is Larry. This is me doing day 15, and I'll also do the premium problem later of the Leetcode Day Challenge. Oh, they're gonna give us a hard one right before a contest. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem, 1269. Number of ways to stay in the same place after some steps. I'm still in Taipei, you can see the background. Also just woke up, but I didn't sleep that well, so I don't know what to make of it. Jet lag maybe, but yeah, I saw the mod, so I'm gonna do the mod dance and mod. Let's mod this thing. All right, so you have point at zero. Each step you can move left to the right or stay in the same place. Given two steps, return the number of ways such that the pointer is still at index zero after exactly two steps. Okay, so then after that it's just constraints, and constraints are 500. So this is actually pretty easy to define, right? Wait, what's all length again? Oh, oh, actually, I think I misread this a little bit. Um, well, I'm trying to think like, oh yeah, outside the way. So you start at zeros and okay. I mean, but it's still, yeah, it's not that bad. I think I think one of the things about this particular problem, sorry, I'm a little bit shaky because I'm literally using the laptop on my lap. But maybe just not look. Maybe you're not looking at my face anyway, and that's fine. But I think for this particular one, I think the key thing to realize is that this constraint is like, oh, we're doing steps per wavelength. That's going to take forever, and it's true. But I think to notice is that you can only move one step at a time. How far away can you be after n steps? And the answer is n steps away, right? So that means that even though this array length is 10 to the 6, you can only really go only 500 steps away. And of course, and that's just in general. If you want to talk about, yeah, that's just in general. And then if you want to talk about the actual problem, which is you have to get back to the first index, right? The zeroth index. Well, yeah, stay in the same place. But yeah, the first index or index zero, then you have to kind of budget the time to go back and forth, which means even then you only go up to n over two steps away or steps over two distance away, right? So in that case, yeah, I mean obviously it's still gonna be n squared, but where n is the number of steps, but that should be good enough for us to start. So let's do it, right? So then now here we have. You can do it in a number of ways. I'm going to do it top down just because it's easier to explain. Yeah, let's just say I'm going to count steps or something. Or not. Yeah, just do count. And then how many? So you have like steps left, and then the current index, right? And then here now we want to return steps left with steps, all the steps left, and we start at zero index. And yeah. So if steps left is equal to zero, that means we have no more steps left. If index is equal to zero, then we return one. Otherwise, we return zero. The base case is just that if we are able to go back to at the end of all the steps, if we're in the first space, then we return one. Otherwise, we return zero. Okay. And then after that, you can only go left, right, or stay in the same place. So yeah, so then number of ways we can go left, we can go right, and we can stay in the same place. Maybe I'm doing this in a weird order, but of course the thing is then now we have to make sure they stay in bounds, right? So if index -1 is greater than equal to 0, if index +1 is less than array length, and that's pretty much it. That looks good, and of course here you can trivially put in like 500 and 2000. And it'll time out is what I meant to say, but I don't know why I forgot to say it. But yeah, so it should time out because this is branching 3 times or close to 3 times on every iteration. So the thing to do is just memorize. And there are a couple of things you can kind of hack around as well. Like I said, index has to be, um, I guess in this case, if you have steps left and then you have index, it takes all the steps to go to index. So you can actually even add something like if steps left. Actually, I'll add in the optimization. No, I think this is fine. If steps left is less than index, right? Is it less than equal to? I'm trying to think. And then we return 0 because we don't have time to get back, right? Don't have enough steps to get back to 0, right? I'm trying to think. So we have, if index is 1 and this is 1, then you do have enough. So I think this is fine. And then of course the other, I mean, this is a very minor optimization, but the other thing is of course memorization, right? So how do we analyze this? Steps left can go from 0 to steps. Index can go also from 0 to steps, though a little bit tighter than that, this optimization, but we'll just kind of ignore that for now. But yeah, has cache, right? Is it and that's pretty much it. After you cache it, actually use the cache, of course. I would also say if you're using another language, you should be more careful about the mods. In Python, I don't have to be that careful per se, but also I did actually do a background of math. It's just that I'm lazy about it. But basically, if this number is less than mod, this number is less than mod, then or this will be just at most 3 times mod, right? And 3 times mod isn't going to overflow for by that long, by that much, by that long. So that's why I'm not worried about it. Let's actually give it a submit, obviously, because sometimes I forget apparently. Yeah, and you can see that even case 4 kind of went fast enough. I don't know how fast it went, but let me double check any weird edge cases. I don't think so. So let's give it a submit. And there we go. Like I said, this is going to be step square and step square space. You can actually optimize the space part if you do it bottoms up. I'm not going to go over that today. I'm trying to go back to sleep, to be honest. And even though my body doesn't want to, I think like it's just going to burn me out if I don't try, at least try a little bit. But yeah, that's all I have for today. At least for this problem. Let me know what you think. I'm gonna do the premium problem next, so stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.